Hello everybody, in this video we're going to be going over indefinite integrals. I'm going to briefly explain what an integral is, as if you really didn't know how to do it or know what it is, and then we're going to solve a couple of really good examples, again basic examples, so we're not doing natural log, we're not doing trig, that's the next video. This is basic, introductory, indefinite integrals. Okay, so integration is just the reverse of taking a derivative. So it's like asking, given a function slope, what was the original function, okay? And integral looks like this. This is called an integration symbol, where you have the function, which is your integrand, and then you have dx. That represents the differential of x. So this is an integral, and when you take the integral, you get an antiderivative. So an integral is an antiderivative. So this is one antiderivative plus c, which is a constant of integration. So again, this is an indefinite integral, meaning we have no bounds or limits. We don't have an a or b here. Therefore, we must always finish our antiderivative with a plus c to account for any constants that we might have, well, I guess, lost, because when you integrate, sometimes many different functions can have the same derivative, so we always have to have that plus c. Now let's jump into a couple of problems, right? So here's a basic integration table. This is basically what we're going to use. It goes from a derivative to integration. None of this might make sense until you actually see a problem, so let's just do a problem so you can for sure see how this works. In this first example, we're going to use the first one that was in that basic integration table with the formulas. Okay, we are given the integral of 5 dx. All right, we're going to utilize this formula down here. Okay. So it says d dx of x equals 1, then the integral of 1 dx equals x plus c. And again, there's a 1 in front of that x, we just don't write it, it is implied. Therefore, if we were to apply this formula, we would get that our antiderivative is just 5x plus c. And if we were to do another example just for the sake of it, let's say we had 26 dx. It'd be the same thing where we get 26x plus c with this formula. It's really simple. Okay, now let's move on. We're going to now utilize that second property or formula, whatever you'd like to call it, where we have the derivative of x to the r equals r times x to the r minus 1. Again, that's our power rule. When we were taking a derivative, that's our power rule. So it's saying when you do this derivative, right, this is what the integral is. And the integral here is x to the r plus 1 over r plus 1 plus c, where n cannot equal negative 1. Let's use this in practice, because right now it looks crazy. It doesn't really make much sense, so actually using it in practice is going to be nice. We're given 5x to the second power. So we have our 5x, and our r is 2. So we must add a 1 to our r, and it's telling us that we must put that over r plus 1. Again, r is 2. There we go, plus c. So we have now successfully applied this. Now, let's simplify this. When we simplify it, we get 5x to the third power over 3 plus c, and that is our answer. You can leave it like this, or if you please, you may write this answer also as the following. Either way is perfectly acceptable. However, that is our answer. Next, I'd like to go over some properties that are super important. So unlike derivatives, when we had our power rule, our product rule, our quotient rule, our chain rule, we kind of are left in the dust here where we can't really do much of that. We kind of have to use substitution for product, quotient, whatever. Like, we kind of have to do that. Again, this video is not going over use substitution. We're going over the basics. In our first property, we are told that we can actually pull a constant out like we could with a derivative. So here, if we have c times our function, we can actually pull out the c and then integrate. Our second property states that we can take our integral part by part, which is amazing. Makes it easier. And our third part is just saying the same thing. You can take it piece by piece, whether it's adding or subtracting it. Now let's apply these properties. It's really easy. It's really simple. Okay, let's apply this first property. Where our constant is 61, we can literally pull out our constant and rewrite our integral. Now all we have to do is take the integral of x to the second power. When we take that, we get 61 times x to the second power plus 1 over 2 plus 1. Again, 2 is our r. So we have, if we're following the previous formulas, right, that we just used, it's x to the r plus 1 over r plus 1, and we have done that here. Now we must simplify this. 61 times x to the third over 3 plus c. Now we must distribute that 61, and we get 61 x to the third. Wow, we ran out of space here. So let's continue writing it over here. We get 61. Again, you can write this however you please. I'm writing it like this, okay? And that will be our answer. That's it. It's pretty easy, pretty silly. Nothing too silly, nothing bananas. Just, I guess, normal. I don't know. Okay, now let's move on to this one. Again, we're going to apply the second and third property. I would have copied and pasted it, but I felt like that was kind of like dumb to do again. So let's get started where we're going to break this piece by piece using that property that we learned. So we have the integral of 5x squared dx plus the integral of 2x dx plus, actually, just for giggles, let's make this a negative just so you can see it really doesn't matter. I mean, it really doesn't. Okay, let's make that a negative 3. Sorry. We have the integral of 5x squared dx plus the integral of 2x dx minus the integral of 3 dx. Okay, now that we have broken into parts, we can just do each one individually. We get 5x to the second power plus 1 over 2 plus 1 plus this next one, 2x, Siri, mind your business, 2x 1 plus 1 over 1 plus 1 minus 3x plus c. Then, if we keep going, let's simplify this. 5x to the third power over 3 plus 2x to the second power over 2 minus 3x plus c. We can actually simplify this guy, right? So let's simplify it. Again, I'm going to write this way. This form is perfectly fine. I just prefer it in this form. Plus x squared minus 3x plus c, where that is our final answer. This isn't too bad. Honestly, it's pretty optional if you want to write it out like this into, oh my gosh, into 3 parts. It's optional. You could just jump from this point to this point. You don't really need to write all of this if you don't want to. It's completely up to you how you want to solve it. Okay, now this next guy. I kind of wanted to make you think critically, because what if you get something like this and you start panicking because there's nothing to do? What are you going to do? Use substitution? Like, that's crazy. Okay, but like, again, we're back. We're doing the basics. So for this, we don't have anything cool like the product rule that we can use. So what we're just going to do is we can simplify this. We can distribute this. So let's distribute it. We have the integral of x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. 2 times negative 2 is negative 4. Again, dx. Let's simplify it further. Okay, now we can take the integral. Again, you can do it part by part, or you can just jump right into it. I'm just going to jump right into it instead of writing it piece by piece, where we get x squared plus 1 over 2 plus 1 minus 4x plus c. Again, I'm going to simplify her. X to the third power over 3 minus 4x plus c. And I'm going to rewrite it because I don't like how that looks. And this is our final answer. Okay, now can you guess what we're going to do here? Pause the video, feel free to try it. We're going to kind of do the same thing we just did there, all right? We're not going to do anything crazy. We're just going to rewrite this because that 2 is showing us that there's a multiplicity of 2. All we're going to do is rewrite it, and we're going to distribute, simplify it, and then find the integral, or the antiderivative. Here we get x times x, x squared, plus x times 2, 2x, plus 2 times x, 2x, plus 2 times 2, 4, dx. Okay, let's simplify her. We get x squared plus 4x plus 4 dx. Now we can pull the antiderivative or the integral. We get x squared plus 1 over 2 plus 1 plus 4x to the 1 power plus 1 over 1 plus 1 plus 4x plus c. We're going to simplify this. And we get 1/3 x to the 3rd power plus 4x to the 2nd power over 2 plus 4x plus c. And we can definitely simplify this, guys. So let's reduce it. I'm kind of running out of space, so I'm just going to erase it and reduce it. So 4 over 2 is literally just 2, right? Okay. So our final answer, right there. We get 1/3 x to the 3rd power plus 2x squared plus 4x plus c. Nice and easy, nothing crazy. Now, what do you do when this happens? Because again, we don't have anything cool like the quotient rule when we had with derivatives. So what could you do? Again, this is just basics. What could we do? What could we do? Think critically. I hope you said that you can just break it apart. What I mean by that is you could really rewrite this as x squared over x to the 4th power minus 2x to the 4th over x to the 4th dx. That is completely legal, okay? Because if you were to squish this back together, it'd look just like this, right? So that is legal. Now we could simplify this. And when we simplify it, we are left with 1 over x squared minus 2, right? Because x over 4 and x over 4 is just 1. And then on the left, we took a multiplicity of 2. So in the denominator, we were left with a multiplicity of 2. 4 minus 2 is 2, right? Okay, dx. Now we have to find the integral, but one problem here. It's not in its proper form. We need the x to the 2nd power to be in the numerator. We can't have it in the denominator, so we got to pull her to the front. So that means that this is now going to be x to the negative 2nd power minus 2 dx. Now that it's in its proper form, we can find the antiderivative. So let's do that. X to the negative 2 plus 1 over negative 2 plus 1 minus 2x plus c. I'm running out of room, so I'm going to write it over here. We get x to the negative 1 over negative 1 minus 2x plus c. Okay. Now, what I'm going to do is I'm going to bring this negative out front, and I'm going to put our x to the negative 1 power in the denominator because it's illegal to kind of leave it like that, right? So when we do that, we are left with negative 1 over x to the 1st power minus 2x plus c. And that is our final answer. Now let's take a look at this guy. This guy still ain't bad. It's really not bad, I promise. It's going to be a little tedious fraction-wise, but it's going to be okay. Let's jump into it. Again, this is an improper form. We can't really do anything with this, so we need to put it in its proper form. To put it in its proper form, we get x to the 1/2 power plus x to the negative 1/2, right? Because this guy is equivalent to 1 over x to the 1/2 when you bring the, wow, that is so hideous. When you bring this guy upstairs, it's now going to be a negative exponent. So that's how we got that, just in case you were wondering, what the heck was that jump? That's what that jump was. Now that it's in its proper form, we can find the integral, okay? We get x to the 1/2 plus 1 over 1/2 plus 1 plus x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. Always plus c, because if you don't do that plus c, the whole thing's wrong. This gives us 1 over 2 plus 2 over 2, right? And that's just going to give us 3 over 2. So I'm not going to write all of that. I think we could all do that basic addition right there. And then, again, what we just did to our exponent is the same thing we're doing to the denominator. Plus, we get x to the negative 1/2. When we do this, we get what? We get 1/2, right? Basic addition, or subtraction, I guess, rather. And again, the denominator is going to same operation. So we get this, okay? Again, this isn't legal. We can't leave it like this. This is so sad. So what we're going to have to do is we're going to have to do the reciprocal. I'm going to do this in a different color so you see exactly what I'm doing. The reciprocal makes it so that we don't have this fraction in the denominator anymore. And what you do to the bottom, you must do to the top. Okay? This cancels it out and gives us that 1 in the denominator, which is just what we want. And when we multiply this to this, we get 2/3 and x to the 3rd, or 3 over 2 power, whatever, plus, okay, now let's do the same thing that we just did to the other guy. We do the reciprocal, we do to the bottom, we do to the top, right? This is canceling itself out. It's going to have a 1 down there. When we multiply 2 over 1 times x to the 1/2, we get 2x to the 1/2 plus c. Okay, you could leave your answer like this, or you could bring it a step further and you can rewrite it. I mean, this is pretty acceptable, but maybe your professor hates that. So I'm going to show you how to write it in proper form, I guess. And you could have 2/3, right? And then you'd have the square root of x to the 3rd power plus 2 times the square root of x plus c. Always plus c. So again, you could write your answer like this, or you could write your answer like this. It's really just your preference, I guess, or your professor's preference, whatever. Okay, let's move on to this guy. I think this is our last one. Yes, yay. All right. This one I just threw in to see if you were getting the hang of it, so please pause the video and try it. I just wanted to see if you were getting there with it. All right, let's jump into it. Okay, we can actually do a few things. We could pull out that constant. So when we pull out the constant, now we have one less thing to worry about. Then we must put it in its proper form. Right? Now we can pull the integral 5 times x to the negative 1/2 plus 1 over negative 1 over 2 plus 1. Again, I'm going to skip some steps because I literally just showed how to do all this. I just wanted to see if you would do it. Like, I don't know. I just thought it'd be cool to see if you, like, actually figured it out. Like, yeah. Okay, whatever. And we're left with this. When we do the reciprocal, we're left with 5 times 2x to the 1/2 plus c, right? Oh my gosh, how dare I forget this plus c. And then 5 times 2 is 10x to the 1/2. And then if you want to put it in its proper form, I guess, could write 10 times the square root of x plus c. And that guy would be our answer. All right, I hope you enjoyed the video. Thank you so much for watching. Again, in the next video, we're going to go over more complex integration problems involving natural log, trig functions, and then after that, use substitution. So if that's something that interests you, please go check out those videos. Thank you. Bye.